In today's video, we'll be talking about polygons and the measures of exterior angles and interior angles, their relationship to each other. So the first diagram here, the first set of questions asks you to find a measure of each exterior angle. Given an interior angle of 60, the exterior angle has to equal 120 degrees because they form a linear pair. Linear pairs are worth 180, so when you subtract out the 60, we're left with 120 degrees. Up here in angle 2, again, it's a linear pair, so when I take out the 155, I'm left with 125 degrees. Angle 3, again, if we do the math, subtract 65, I get 115. So angle 3 has to be worth 115 degrees. So by using linear pairs, we're able to determine each exterior angle. It then asks me to find the sum of each exterior angle. The exterior angles will equal 125 plus 115 plus 120. When we add all that up, we get 360 degrees. The exterior angles will equal 360 degrees for a triangle. We can also find out about the interior angles. Maybe that'll be useful for us later. 65 plus 55 plus 60. That means our interior angles of a triangle will equal 180, which hopefully we remember. Triangles always add up to 180. The interior angles of a triangle always add up to 180. If we put those together, we should have a total. All of our angles should add up to 180 times 3, because there are 1, 2, 3 linear pairs. Linear pairs of 180, so we get 540 degrees by multiplying 3 times 180. We get 540 by adding 360 plus 180. Okay, so now let's examine this quadrilateral. If I extend this side out, I would get an interior angle of 65 would give me an exterior angle of 115. Interior of 110 would give me an exterior of 70. Again, interior of 65 gives me 115. And 120 gives me 60. So if we are to add our exterior angles again, 70 plus 60 plus 120, not 120, 115 and 115, we get 360 degrees. If we were to add our interior angles, 110, 65, 65, 120, we also get 360 degrees, which makes sense because there are a total of 4 linear pairs worth 180 each, which gives us a total of 720, which is a result of adding our interior plus our exterior to get our total. All right, everything seems to be fitting together really well. So finding the measures of the exterior angles of a regular octagon. Okay, so for this exercise, you might not know what a exterior angle of a regular octagon is. So I'll let you know that it's 45 degrees. Regular octagons always have exterior angles of 45. So my exterior angles, right, if I have 8 exterior angles, and each of those are worth 45 degrees, I get a total of 360. 360 degrees. Now, if my exterior is 45, my interior must be 135. So my interior angles, I have 8 angles that measure 135. So if I was to multiply those together, I would get a total of 1,080 degrees. So my total, again, if I have 8 45s and 8 35s, then I have 8 180s based on the distribution property. If I have 360 and I have 1080, that gives me a total of 1,440 degrees, which is the same as 8 times 180. So this little formula seems to be working out rather consistently. I see in all 3 examples, the exterior angles are 360 degrees for a triangle. For a quadrilateral, the exterior is 360. For a octagon, it's 360. And in fact, for any convex n-gon, your exterior angles will always add up to 360 degrees. So given that each vertex of a polygon has a linear pair, interior plus exterior, we can expand this to determine the sums of the interior angles as well, right? We were talking about the total, right? The total is always the number of sides times 180. If we subtract the exterior angles, which has always been 360 degrees, we will get our interior angles. So we kind of have a little formula, n times 180 minus 360. That is going to be our formula to find the sum of the interior angles of any convex polygon. So on the next page, again, our formula is n times 180 minus 360, the sum of the interiors. So what if we wanted each interior? Well, each interior, if I have n sides, then it'd be n times 180 minus 360 to get the total, and then I would just divide that by the number of angles. How many interior angles do I have? And that's all I would do. That would give me what each interior angle measured. And again, this is only works for regular n-gons. If they're irregular, then they'll all be different from each other. You can't find that from the sum. You'd have to find each individual one. So let's talk a little bit about shapes. Hexagon is a polygon with 6 sides. A heptagon is a polygon with 7 sides. A 30gon has 30 sides. So given that information, we want to find the exterior angles. Well, it doesn't matter how many sides there are. The exterior is 360 degrees. The sum of the interior would be 6 times 180 minus 360, which would equal 720 120 degrees. If I wanted to know what each exterior angle was, it would be 360 divided by 6, which gives me 60 degrees for each exterior. For each interior, I would take the 720 and divide it by 6 to get 120. Again, that gives us a very clear, very important relationship between the interior and exterior angles, particularly that they equal 180 degrees whenever you add up the interior and the exterior, as we saw in the first problem. Heptagon. Exterior equals 360 degrees. Interior would be 7 times 180 minus 360. And when we do that, we get 900 degrees. We divide each of those by the number that we have, and that would give us what each one is worth individually. We can round this decimal to 51.4. So that's it. Exterior, each interior would be worth 900 divided by 7, which would give us 128.6. And again, these two have to equal 180 degrees. So the rest of these you could practice by following this format to get the rest of those. On these examples, we're looking at measures of each exterior angle of a regular polygon and trying to figure out how many sides the polygon has. So if the exterior angle is 4, what I did was I divided 360 divided by the number of sides, and I got the exterior angle. So if I set up that equation, I could solve this equation by switching the n and the 4. So I'd have 360 divided by 4 degrees, which would give me 90 sides. So if given the sides, I divide to get the angles. If given the angles, I'll divide to get the sides. But again, we're working with exteriors, so it's always 360 divided by the number that you're given when given exteriors. So 360 divided by n gives us 40 sides. So again, these are just more practice problems for you to work through. If you have any questions, feel free to ask when you see. If we're looking for the sum of the measures of the interior angles of a convex polygon, we're just plugging that into our formula. Dodecagon is 12, and our formula is the number of sides times 180 minus the 360 degrees for the exterior, which gives us 1,800 degrees. So we're just plugging in the value into our formula. Now they want the measure of each interior, so not just the sum, but then to also divide. Nonagon is 9, so it'd be 9 times 180 minus 360, but then you would divide it again by 9 to figure out what each individual angle measured. And and we ended up with 140 degrees. So you should be able to, again, complete these other ones for additional exercises. Those would be worked out in the answer key, which you can check on Blackboard as well. So this next problem talks about the interior angles of a regular polygon. I've been given the interior angle, and I want to figure out how many sides there are. Well, we just did that when I was given exterior angles. It was 360 divided by the exterior angle. A very simple formula. So working with an interior would be much more complicated. So I'm just going to switch from interior to exterior by just subtracting. Since my exterior is now 18, I just plug that into 360 divided by 18. And when I do that, I get 20 sides. Again, if I wanted to use the formula for interior angles that I used up here, that would be a much more complicated problem. It's much easier to switch from interior angles to exterior angles and then do 360 divided by your exterior angle. Practice a few of those problems. And then when you're ready to continue, you can look at number 22. We're trying to find the angle ABG. So that's x. Again, this is a central angle. Central angles have to always add up to 360. So if I find ABC, that's a hexagon. Hexagons are 6 sides times 180 minus 360 divided by 6, and I'll get an angle of 120 degrees. So I know this has to be 120. And then I have a pentagon, so 5 times 180 minus 360 divided by 5 will equal 108. Once I have all 3 of these angles, these 2, and the one I'm missing, I would add up all 3. 120 plus 108 plus x has to equal 360 degrees. So I get 228 plus x equals 360. So x has to equal 132 degrees, also known as C. '23 is another example, except I know that this is a rectangle, so that has to be 90, and this one's 90. So now find that side there of an octagon, and then add them all up and set them equal to 360. Octagons we found were 135. So if I do 90 plus 90 plus 135 plus x, it has to equal 360 degrees. So solve that, and you would have your answer. The last set of problems we'll talk about are when you're given a quadrilateral or a pentagon, and you're given interior angles, and you're trying to find x. Quadrilaterals always add up to 4 times 180 minus 360. Quadrilaterals add up to 360 degrees. So if I was to add up all of these, 2x plus 3x plus 2x plus 2x would give me 9x. Negative 41 plus 7 plus 7 would equal negative 27. And that would have to equal 360. So from there you could solve x if I divide that by 9, I get x equals 43. in number 26, it's a pentagon, which is different because pentagons are 5 times 180 minus 360, or 540. So the process is the same. And let's change this to 1 and 1, just to make the problem a bit easier. So 1 plus 2 plus 3 plus 1 plus 2 is 9x. 80 plus 60 plus 80 plus 60 plus 80 would be 360. And that has to all equal up to 540. Adding up each of the interior angles has to equal 540. So 9x equals 180. X will equal 20. All right, so the next few problems are a bit of a challenging problem. Let's give it a try. And again, the answers will be on Blackboard when I put the document up. So you can check those, and then we can talk about it in class, ask any questions you might have next class.